Hi, it's Gadget UK here again. This time we're looking at something for the BBC. This is the Beeb SID PCB. So the original dates back to 2009 and was created by Martin Barr. Very cool. So what does this board do? Well, it allows you to connect a SID chip up to your BBC. Now, you can support this. The board can support the 6581 or the 8580. I'm going to go with a nano swin SID actually. There's a couple of reasons for that. One, I don't really want to waste, is that really the right phrase? Yeah, waste a C64 SID chip on a BBC. It really, in my mind, belongs in a C64. But you know, there's going to be always excesses of these things. You may have a board where the components are faulty on the board, but the SID's okay. So you know, that's a good use. You could reuse it on one of these. But if I use a nano swin SID on here, I'm not, diminishing any of my actual SID stocks, if you like, from other boards and things. And the nicety there is you need to obviously provide the VDD voltage, which, you know, for 6581 is 12 volts, for an 8580 it's 9 volts. So this board here has got the options for the different regulators and some jumpers there to switch between, you know, what your output is, 9 volts or 12 volts, etc. And in fact, I think the way it's designed is you can take 12 volts straight from the BBC and just feed 12 volts. You wouldn't need the regulator. I think one of these is for a 7805 perhaps. Yeah, I think it is. And I think the regulator is optional. You'd only need the 9 volt regulator there if you're using an 8580. But with the 6851, my mind's going blank, with the original SID there, you'd just pass the 12 volts, you know, straight through from the connector here to the VDD pin, wherever that is. And there's a couple of positions there for the filter caps. That's the other thing, you know, so I'm not going to need the regulator, I'm not going to need the filter caps. I can literally just feed 5 volts to the VCC pin on this. The VDD pin's not used on the nano swin SID, and that's it. We should be away. Now there's a couple of different options to route the audio. You can have an audio connector. I'm not sure where that goes. There is one for a power connector, I think. Again, I'm not going to use that. And it connects up to the BBC via the 1 megahertz expansion bus here. You know, so we'll stick a 34-way IDC connector. I don't think I've got one actually. I'm just going to stick some pin header, 2 strips of pin header there. That'll be fine. As long as I get the key the right way around, I'll just mark it so I don't mess the key up. So that's how you connect it to the Beeb. Now it's got a pass-through. You know, there's an in and an out. So if you're using some other peripheral on the 1 megahertz bus there, you don't need to populate these resistor array banks here. So that's what those are for, the termination resistors, if you're not using the pass-through. I'll keep one of these as a spare for myself, just in case I ever decide to redo it with proper, keyed sockets and socketed resistor arrays, because then I could always use it. You know, if I want to plug something else into there in series, I could do that, and I wouldn't need those resistors. But there's just 3 TTL logic chips you need on here. I think one of them is a 74 LS030, I think it is, an 02 and an 04, I forget which way around those go. And obviously, there's going to be a couple of the caps and things on here, decoupling caps. There might be a smoothing cap somewhere, or 1 or 2. I think there's a few positions for them down here, but I'm not going to need them because I'm not going to have all the different supply rails. I'm only going to need 1 for the 5 volt rail. I think that's probably it. Maybe 1 to couple the audio out. So maybe 2 in total. There's a position here for an LED. I'm not sure where that connects. I'm guessing it's probably just feeding off the 5 volt rail or something like that. But yeah, coming back to the audio output, yeah, you can say, like say, feed it out of a socket. That might be what this is, or it could be this one over here. No, I think that's 12 volts input, isn't it? I think it's a 12 volt connector there. So yeah, you could feed audio out there, but you can set this jumper, I think, and you get audio going to the bus. So in theory, it should pass out through the BBC's speaker. Or in my case, if I switch it over to line out, I should get it out the line out. There's a couple of pads here for pot X and pot Y, because obviously you could read the signals from those there, connect up a mouse or something. Obviously you need to write code to work with it, but it's nice that they've added that as a feature. As you can see, it's come out quite nice actually. These boards are pretty good value. I'll also post a link to the Beeb SID stuff as well. The link on the Stardock forum and the wiki. You've got like a web page there with links to everything, explains how it works, some samples, examples I should say rather. You can download some of those example programs, and it plays some SID music for you. So I don't think anyone's developed an actual SID player. I think one of the things is this is going to sit at a different base address than the original SID would have sat in the C64, so that could cause some issues, but I would imagine it not being too much work to write, alter the base address there. So maybe you could, in theory, write a SID, I would think, well yeah, you definitely can, you could write a SID player, so you could load .SID files. I might have a tinker around with that myself, just see if I can do something in BASIC, because you can use BASIC to interact with this and to get this to play music and stuff. We'll perhaps have a look at that later on in the video, but right now I think I'm just going to get cracking on this and start soldering things in. I might just show you a few things to solder them in, but there's nothing to it really. If I give you an example of one or two things, it's going to be representative of what you would need to do for most of the board. So we'll start with the connector there, and as I say, I'm just going to go with some pin header, 2 strips of pin header here. And the way I'm going to do this, just to make it easy and get it straight, is I'll connect this up. You can see I've got a Rainbow Islands style cable here. So we'll just, we'll get that roughly the right place, plug it in. That's it, and that's just going to allow me to, use that to help. I'll just anchor a couple of corner points, make sure it's totally straight. And then solder all the remaining points. Yeah, so I don't imagine this taking too long. We'll just solder one pin, and then I'll just heat it while I put some pressure on the connector. Yeah, what I need to do now is get that straight. You can see that it's just not straight at all. Yeah, that's looking a bit better. So I'll just do that at the far corner there as well, and I'll do the same thing. I'll just heat it and put a bit of pressure, just make sure it's nice and flat when it is. I can now commit to soldering the rest of the pins there. So there we go, disconnected the cable, as you can see, nice and straight there. Yes, the next thing I need to do is get the socket on. I could use a dual white one. Might be easier with the Swin SID because it's probably got pins, rather than flat legs. But then again, the pins would perhaps make a better fit there actually. And with removal and insertion stuff, the legs are not going to get, the socket legs are not going to get widened. If you use one of these, you see, with the Swin SID initially, it'll widen the slots there, the gaps. And then when you come to put an official 6581 in there, or an 8580, it won't make as good fit. A ZIF socket might be an idea, but yeah, you're not going to have all the clearance around the edges there for a ZIF socket. So I think I'll go with the turn pin for the moment. So I just need to inspect that, make sure I've got some good connections there. I'll clean it up at the end. I think we'll get these sockets on for these 3 next, and perhaps the 3 caps. There we go, those are the 3 smaller sockets there. I need to get the 3 caps on next, I think. You may think it's a bit pointless sticking these on, and it probably is. I could have just soldered the chips straight on there, but you never know, I could wire it up the wrong way or something could fail. It's just a bit easier if it's socketed. What are these, a few pence each or something, it's just saving the time. So before I get the caps on, I'll just put the resistor arrays on actually. We've got four of these 2K2 resistor arrays here, and you can see the way these work is you've got a common pin, the one with the notch there, pin 1, and then you've got obviously 2K2 resistors all the way along there. So I just want to check, it does say 1, you can see it from this distance, there's a 1 marked on the silk screen there, so that's a given, that's where you stick your notch. But this has also got a 1 on this side, so I just want to just double check. Yeah, they're joined, and I'm guessing, yeah, they're joined. So you have, one with the notch to the left, and then one with the notch to the right, so you'll have to flip them around. Yeah, I'll see if I can show you. So you've got the notch there, so that's going to go that way, and then there's a hair there. This other one, you've got the notch to the left, so you need to flip it around so you can see the back side of it in order to mount that one here. And as I say, some people put sockets there, like turn pin sockets, a strip, and then you can plug them in and remove them depending on whether you're using the pass-through. And these are actually in parallel, so doesn't matter which, if you're only using one like I am, it doesn't matter which one you use actually. And just looking at the diagram, correction, those aren't the filter caps, these are the filter cap positions here. The first 2 pins go to these 2 pads here, and then the 3 and 4 there go to these 2, and they've just got, this one here is just joined to there, so you've got like a, different size pads for different size capacitors effectively, physical. So I just need to populate C1, C2, C3, C4 with 100 nanofarad. Stick 1 microfarad up here. That's the coupling cap for the audio coming out. And I think that should be it, actually. It's just a question about the resistors and the LED. I might not fit the LED for the moment, so there is a 470 ohm resistor that feeds that LED, but it seems to go to a jumper. I'm not sure where that's designed to connect to. So just for the moment I'll leave that off. There's another resistor position up here. That might be for coupling the audio. Yeah, that's the standard 1K pull down that I think you need, actually. So we'll stick that 1K resistor on there as well. So there we go. I think that's all the components I need. I might stick the LED on there at some point, but for now I think I've got everything I need. I've got the jumper there to pass the audio through, the resistor to pull down the audio output, coupling cap, the output. 74LSO4, that's reclaimed, that came from a printer. 74LSO2, that's reclaimed, that was the one that was originally on the Beeb board there before I swapped it out for a HC02 actually. And then I've got a brand new LS30 in IC4 position there. Funnily enough, on the schematics you can't quite see it, it says IC4A on the gate, and then down below it says IC5. I don't see an IC5, so I think that's a typo. Yeah, there might be transistors, I'm not sure, just to isolate the supply. It says TR2, TR1, yeah, I suspect they are. I suspect the transistors, MOSFETs or something. So I don't need those. All I need to do now is feed 5 volts into this and connect it up, and in theory it should work, I think. Before I do that though, I'll just make sure we haven't got a short between ground and VCC. And I'll just make sure that wherever I tap 5 volts from, probably over here I would think I'll run away from there, just make sure it does go to the relevant places on here. And then the final thing I need to do before I connect it up is just work out which way this is going to need to connect to the BBC with regards to this cable here, and just do some connectivity checks just to make sure I get these both the right way around. I would suggest the easiest way to make sure you get it the right way around, if you've not got a keyed thing on here, well actually in terms of working out which way your key needs to go before you put it on, you'll notice on this left row here, all these pins at the bottom here are all joined together. That's one large ground strip, I think. So yeah, so I think we'll assume that's all ground down there. All I need to do is just measure on the BBC for a similar pattern there. If I just probe the pins there, and I should see that same strip of connectivity where they're all joined together, and then I can just work out which way to put the cable on. Yeah, so just probing under here, if you go to the bottom row, you'll see that we've got shorts all the way along there like that, so those are going to be the grounds again. And just to confirm, check the opposite corners and things as well, nothing there. Let's do that top one, nothing there. We might get the odd pin joined, I suspect, but no, there's nothing there. So the ground is definitely the bottom row here on the left. So we'll just plug one end in, carefully get that in position, make sure it goes in properly on both sides. Yep, that's pretty firm. And then I just need to work out which pins on here are shorted together again, and just marry them up to that, where I showed on the board. Yeah, and in my case it's notch here to the right, actually, the way that is. So I just need to deal with the 5 volts now. Bear in mind, there's a couple of different ways I could do this. I could stick this into a case, which I might do, I'm not sure, and it'll just be out the front of the thing, because the cable's not very big. You wouldn't want that cable to be super large anyway, really. Just for noise reasons more than anything. But what I could do is you could fold it in such a way that it goes inside the case. You could perhaps fold it so it goes under the connector there, inside, wraps on the inside. It might be quite tight, but I suspect you could probably do that, and then actually just mount this internally. So I might look at that at some point, I'm not sure. But right now I just want to just test the thing. So I'll clean up the PCB before we try it as well, but I just need to work out where to tap 5 volts off. And as I say, you could, in theory, if you can find 5 volts on one of these over here, maybe the disk drive's got 5 volts coming out, or maybe the printer, I'm not sure. I might just temporarily solder a wire, actually, to the VCC pin somewhere on here, with this 5 volts, and just stream it across. Oh, for sake, man down. This has died. I'm glad I didn't use an actual SID. Yeah, I've killed it, and I've killed it with latch up. So what happened last night, I obviously had this connected up, and I did check my wiring. The one thing I didn't do, and it's an absolute critical mistake, learn from my mistakes here. What I should have done is removed the SID and measured on the PCB the 4th pin down here and the ground's in the bottom left there, I think, and the 4th pin down here on the right hand side, you know, pin 1's at the top, the notches here, yeah, 4th pin down here, should have had 5 volts, and I didn't, because this board is designed to have regulators on there, and I've just bypassed that. I don't want regulators on there. I was just to start with was testing with 5 volts coming straight from the Beeb straight to the board, and the place I connected it was not the correct place actually, because there are components missing and the jumper missing and all the rest of it, you know, which you use to specify which size regulators you're using, etc. Now bear in mind this only needs 5 volts, but the 5 volts was missing, so it had a ground, it had address and data bus, read write pin, chip select, clocks, everything was there, but it didn't have 5 volts. And whilst it seemed to make some weird noises and things for a short period of time, I only tested it for a minute or two, it then stopped making noises, and I noticed that this chip here was getting super hot, like, you know, you can't touch it. So there's a short, and I think we've had a latch up scenario. It's a similar thing that's happened to that Nintendo 64 memory card I showed in a previous video. So that's now 2 things that I managed to kill myself. Yeah, this is not going well. Generally, I've fixed everything I've looked at for the last 5 years, I think, with the exception of Beeb SID Neo CD, which, had I had more time to spend on that and some parts, I think I could have fixed that ultimately. But, and I'm not being big-headed here, I'm just showing that with determination and patience, you can always fix anything. I think I can fix this. Now, I have contacted the author, Mate Sebok there. I don't know whether he's going to be able to provide anything, but I have told him the part number that's on here and shown him, he asked for a close-up of the chip to see which revision it was. And I have said, is there any chance I can get a pre-programmed one of these? Even if it's just on a bare PCB, I don't care, even if it's 20, 30, 40 euros, I'm not bothered. Because he's not going to sell these anymore, and if I can't replace that chip, this is just bin fodder. Now, in theory, the latch-up could have killed other things as well, but generally, I think the odds are slim. I think it's just going to be that one chip. I did test the temperature of these underneath here and they're not getting hot at all. So yeah, the Atmel MCU on there has died. I forget what it is, it's something like a Mega 168 PA or something. So yeah, I was gutted, absolutely gutted. And I did just confirm by sticking it in my C64 to see what happened. I mean, I powered it initially, afterwards, on my bench power supply with just ground and 5 volts to see if any of the LEDs came on. They didn't, and it started to get warm, but not as hot as it was when it was in use. So I mean, it may well be that it's lost the firmware and the I/O pins are doing some random stuff or something, because when I stick it on the C64, all the LEDs sort of flicker on and off as if it's doing something, and it starts to get hot, but the C64 won't boot, which makes me think there's random stuff coming out on the data bus there, probably. So yeah, gutted. Well, after chasing a few problems, which I'll explain in a minute, as you can hear, it's working. Sweet. Oh yes. One of the problems with these black PCBs is you can't see the traces very well at all. You need a lot of light and magnification to be able to see them. So that's one thing I would say, if you're going to get your own boards manufactured, yeah, black looks nice and sexy and stuff, but it's hard to see the traces. And if you're working with a prototype or something, or or the not very good quality boards, you may find you've not got a connection somewhere and you can't see where the break is. You might have to just do a lot of connectivity testing. I've ordered some of these pads here with sticky backing, and I think I'm going to mount this internally. I've also ordered a shorter IDC cable, but for the moment I thought this is going to be just sat at the front of the BBC when I've got this connected. So I've got some of these old ones from a PC here, and I've just cut the ends off. They usually have like a little plastic notch that you slide into a metal case there on a PC. Now the holes aren't quite big enough, and it's going to be the same with the ones I've ordered. They're going to be the same size as these here, the same plastic fitting. So all I'm doing here is just using the PCB track cutter just to widen to that size. As you can see, it's super easy to cut through there. Okay, that's done. But then it's still not quite wide enough. So if you just go at an angle like this, as you rotate around the circumference of the circle there, it starts to get to the point where you've got no resistance, and you've increased it by another millimetre or so. And it is perfectly spherical. It looks tidy. As you can see, that's not too bad. Very close to the edge there, but nevertheless that should work now if I just push that through. There we go. So at least now the underside is not going to make a contact with the carpet. Shouldn't be on the carpet really, but I've got no other way of testing it just for the moment. So it's just a little bit of protection. And you can see the mods I did here. I think a minute ago when I was testing, when it showed you it working, I had the wire joined to the centre pad of that jumper there. So I've joined that jumper there to say we're using a 5V input rather than a 5V regulator. Connected to the 5V input because it's marked on the board there. And then where there would be a MOSFET over here to sort of isolate the power from the Beeb side effectively, I think. I've just got a link across there because I'm not using the MOSFETs at all. In the next part we'll mount this internally. I'll show you some, we'll listen to some other SID tunes and things on it. And I think there are a few games that utilise it as well actually. So the other thing I've got to show you here is a cover actually. They call it the ashtray cover. It's the cover there for the hole. So it's got the little grips around the outside there. It's been 3D printed this. On first inspection it looks pretty good, but can you see? It's a really smooth, soft surface, but you can just see some of where the lines were, and it kind of makes it look dull. Can you see that at the right angle? It looks awful, actually. So whilst it fills the hole, and it could be better, well, we can improve it. I'm going to cut a piece of acrylic stuff. I'll show you, and stick it straight over that, and then that should fit in there, and it should look all right. Yeah, I've got some of this matte vinyl here, so I'll just cut a piece the exact size and stick that over there. Actually, that doesn't look too bad. Obviously it's protruding a bit because of its, the height there, but with that matte finish on there now, it looks sweet. So I've just worked out the last problem with this BBC. It's been suffering from, old computer syndrome, whereby when it's not being used for a week or two, you switch it back on and you can't get it on. Sometimes you'll get the flashing cursor there like the keyboard's not detected, and other times you'll just get a single tone. And if you disconnect and reconnect the keyboard a few times, it usually then springs back to life, and it's been driving me nuts. So I took off the ribbon and swapped it around the other way, same thing. And then I suddenly realised, I tried to clean these pins up here, because you can see they're a little bit bent, especially the ones on the sides. And the pin just, it's not doing it now. Oh yeah, it is, it's wobbling. You can't really see it moving here, but I thought it must be a dry joint here. And I'll put you on macro and you can have a look. Can you see around that end pin there? And the one next to it, and I think the one next to it. Those three pins there are all dry joints. Well, it's incredible and super annoying, because that has created me various problems a number of times actually when I've been trying to do these videos and trying to use the system, trying to make sense of it. And it's like, say, what would typically happen? I'd just not use it for a week or something, and then it wouldn't power back up, and I'm like, oh my god, what's the cause of this? It's just driving me nuts. Yeah, the problems with this Beeb seriously never end. While I'm here, I'm going to reflow the others as well, I think. So I think I'm going to mount this internally. This little display is just for the moment. I mean, it's just taped, you know, this like double-sided sponges, if you like, under these plastic pads. So I can literally just detach it and desolder the three wires there, the signal, audio signal, ground, and +5, and mount the thing inside. But this little board that I've been tinkering around with here to get the display working how I want it, I'm going to use that in my transparent C64 actually. So I mean, whilst I could have this external, I mean, it's got little feet on it. I would really need something underneath there. I could stick something onto the feet, a piece of plastic or something underneath, try and, you know, keep it away from carpet and stuff. But ideally, I think it's going to be better suited to being internal. And I've got a shorter ribbon, one that's about half as long as this. So the ribbon should just go straight, fold back under the keyboard. I'll have to take the motherboard out to fit it in there. You know, through the little gap in underneath. You'll see in a minute what I mean. And then I should be able to mount this upside down using those feet with some stickies. In fact, I've got some other stickies, some larger ones, brand new ones. So they're like this with the plastic bits that protrude through. So I can just clip 4 of those on, stick it on the underside of the lid. So I've got you all set up there. I'll load Sanction. I'll show you this in the dark in a minute as well, just for comparison, because it looks fantastic in the dark. The greens perhaps aren't as good as the yellows actually, they're not as bright. I might get some brighter green. So Carousel, this is one of the games that actually utilises it. I'll do a direct capture of this as well, I think. So some of the discs you get for the SID, the demo discs, do this, where you get bad command at line 90 or whatever, line whatever. If we just do list 90, I forgot the command for a minute, you can see it's doing an at disk. Because I'm using the Super MMC here, what I need to do is change that to 90 at card. And if we run it, you will see it works. So I think this is one of the Ocean Loaders remix, so it sounds different. Don't expect this to sound exactly the same as the Ocean Loader. This is a remix. It takes a while for it to relocate the SID, because normally it would be in a different memory location. I think it's shifting it down before it starts to execute it. Yeah, so it sounds very different, but it sounds like this on a C64. It's just been remixed. Personally, I prefer the original. I don't like the remix at all. But with using SID Edit and a few of the tools there, it is possible to convert SID files, yourself to the C64. Just take a bit of effort, Some are easier to do than others depending on where they're located in memory. So yeah, I'm not a fan of that one. Let's try the next one. So I think this one's Outrun actually, so we'll output on the SID.
1, 2, 3, hit it. Outrun. Outrun. Outrun.
So there are a few things to point out. I don't know whether you noticed, but the direct sound captures, it didn't sound as good as I think it should sound. And there could be a few reasons for that. There's a pull down resistor, as I mentioned earlier, which is correct when you're using the 6581, or is it 8580, I'm not sure. Yeah, one of the revisions there needs that pull down, the other one doesn't. So it could be because I'm using a Nano Swin SID. Now the Nano Swin SIDs output less volume as well. The other thing is this is just a straight Nano Swin SID here. The Swin SID Ultimate is far superior in terms of its accuracy of emulation there. So hopefully, you know, I'll be reporting back in the next video on the state of that Swin SID Ultimate there. Hopefully Mate will be able to fix the one I've sent off to him. It could be a number of months actually, I'm not sure, so don't expect the next video in a rush. But in the next video I'll mount this internally. We'll try and get the output a little bit better. It may also be the coupling cap here, that might not be optimal either. And also the other possibilities, obviously this goes through the BBC's sound output there. That could be the issue of why it doesn't sound so great. I mean, it sounds fantastic on the TV. It's just when I did a direct capture I thought actually it just sounds a little bit fuzzy, a little bit not very clear, you know, kind of hard to put my finger on. And this board, by the way, yeah, I can't really show you the underside of it. I'll perhaps show you that in the next one. But there's about 30 wires under there. I totally hacked away at the original circuit. It was just a cheap board from China, but it didn't work the way I wanted it to, actually. So what we ended up with is it doesn't behave as just like a volume thing. You'll notice like this LED here lights with like bass pulses and things. This one indicates like clipping, and you will have seen throughout the video that with certain frequencies, some of the LEDs, they sort of pulse. They pulse with the strength of the actual tone, which is what I was kind of going for, actually. It's ended up working really well, but I will use that little board inside the clear C64, as I mentioned earlier. And this will be, as I say, this will be mounted internally in the next video. So please like, share and subscribe. I'll play some Cybernoid 2 now, just to close this video up. Thanks very much for watching, and I'll catch you in the next one.
This is the Acorn VVC computer.